Chapter 5, Section 5, Performing Function Operations. What we have to worry about here is function notation. Function notation is just taking different equations that all look similar, that are all y equals, and giving them different names so you know which one you're talking about at which time. So if we had, my pen here. We had y equals 2x plus 1, and we had y equals the square root of x, and we had y equals 3x squared plus 2x plus 1, and we had y equals 9 square root of x minus 2 plus 3. And we wanted to know which one we were talking about at which time. If I just said equation y, you don't know which one of the four. So instead, they write them as f of x equals 2x plus 1, or g of x equals the square root of x, or h of x equals 3x squared plus 2x plus 1, and j of x equals 9 square root of x minus 2 plus 3. The y and the f of x mean the same thing. F of x is y. It's the output of the equation. It's the vertical part of the graph. The little x inside tells you which variable is in your equation. We're using x. So a lot of times they'll say things like, well, h of t, where h is the height and t is time. And so the letters match to what the things mean and are. But now with the function notation, I can tell you, take the f equation and add the g equation. And that's all that we're doing with function notations and operations in function notation. So here's a little chart here that tells you what it means. So if you do f plus g of x, x is the variable inside the equation. That's where you're going to plug stuff in. And they just want you to add them together, right? So f plus g of x, or f of x plus g of x, same deal. That's what they want you to do. Same thing with minus. Same thing with right next to each other. It means times. Same thing with quotient. It means divide. Of course, as long as nothing in the bottom makes it turn into 0. So let f of x equal 3 times the square root of x, and g of x equal negative 10 square root of x. Find f plus g of x and state the domain. Then evaluate the sum when x is 4. So we've got three things to do. We have to do this part. We have to do that part. We have to do this part. We haven't talked much about this. Domain is where can it go left and right. Right? And there's a domain and there's a range. Domain is the x values you can use. Range is the y values you can use. Sometimes there's limitations. Okay? If we have an equation like 1 over x, where x is in the denominator, that's a problem. Because you can't have a 0 down there. This is a no-no. So our limitation in this situation would be all real numbers except x is not equal to 0. That's our domain. So you'd say all real numbers, x not equal to 0. You can use anything else down there, you just can't use 0. And then if something was in there that wasn't just x, if it was like x plus 2, well, now you could use 0 because 0 plus 2 is 2. But if you used negative 2, negative 2 plus 2 makes a 0, and that's a thing. So x couldn't be negative 2 in that situation. So you just have to worry about those kinds of things. If you're doing square roots, it's got to be positive because you can't do negative square roots, that kind of stuff. So we'll just look at those as we go. But let's look at f of g, or f plus g of x. They want us to take 3 square root of x and add negative 10 square root of x. That's all they did. Take f of x and add g of x. And then we're going to state the domain. So let's do that. They have to be like terms. They're both square root of x's. So 3 of them and negative 10 of them is negative 7 square root of x. And state the domain. Well, with square roots, even roots, x has to be greater or equal to 0. That's our domain. Okay? So 7x, that's our answer of f plus g. Our domain, we just have to worry about this one because x needs to be greater than or equal to 0. And then it says solve it for when there's a 4. So negative 7 square root of 4. It would look like do f of, well, sorry. It would look like do f plus g of 4. So instead of this f plus g of x like they had, instead of the x, what we're doing is we're plugging in 4 where x was. Okay, so my x was inside here. I'm just going to plug it in right there. And I'm going to do the square root of 4. So that's negative 7 times 2, which is negative 14. So we got 3 answers. We've got what happens when you add them with the x. We've got the domain for that. And then we've got what it equals when you plug in a 4. Let f of x equal 3x to the third minus 2x squared plus 5. And g of x equal x to the third minus 3x squared plus 4x minus 2. Find f minus g of x and state the domain. Evaluate the difference when x equals negative 2. So we're doing f minus g. So I'm going to write f first, 3x to the third minus 2x squared plus 5. And we're going to subtract x to the third minus 3x squared plus 4x minus 2. We just did this back in chapter 3 sections when we were adding and subtracting polynomials. That's all this is. The reason I put the parentheses around it is because it's this whole thing minus that whole thing. Everybody inside the g of x gets subtracted. So the way I like to do these is I like to get rid of the parentheses and set everything free and take the distribution. That's a 1 times everybody, so it's just 3x to the third minus 2x squared plus 5. But this changes everybody's signs. Negative x to the third, positive 3x squared, negative 4x, and now positive 2. Now look for your like terms. There's 3, 2, none, 3, 2, 1. If you want to stack them on rows where all the x to the thirds are in line and the squares are in line and the x's are in line and the constants are in line, do it vertically. That's fine. I'm a horizontal kind. So 3x to the third minus x to the third is 2x to the third. And negative 2x, and I did that one. Negative 2x squared and positive 3x squared is just an x squared. Negative 4x is the only one there. And 5 plus 2 is 7. Now I have to worry about domain restrictions. There are none for this. Any number can be cubed or squared or its thing. So the domain would be... you could do the big R for all real numbers, or you could say all real numbers, whatever way you want to symbolize it, okay? And then we have to plug in the negative 2. So everywhere there was an x, this is how I like to do it, put a parenthesis and plug in what you got to plug in. And the reason I do this is especially if you're going to type it in the calculator, you need those parentheses around those negative numbers so they work the right way. So negative 2 to the third is going to be negative 8. 2 squared is 4. Minus 4 times negative 2 is going to be positive 8. And then plus 7. 2 times negative 8 is negative 16. Negative 16 plus 4 is negative 12. Negative 12 plus 8 is negative 4. And negative 4 plus 7 is 3. So we've got the equations when we subtract them. We've got the domain. And we've got what happens when you plug it in. All right, f of x is x squared, and g of x is the square root of x. Find f times g of x and state the domain. Then evaluate the product when x equals 9. So I'm going to do f of x times g of x. So that's x squared times the square root of x, which is just x squared square root of x. Now, we could say x squared times x to the 1/2. Now, whenever we do this, the same base, we add the exponents, so it's x to the 2.5. Okay, x to the 2.5, or 2 times 2 is 4 plus 1, so x to the 5/2. You could write it like that. You could say the square root of x to the 5th. You could say the square root of x to the, that's not my x. x to the 5th. Those are all good ways to say that. Let's double check the book and see what they say on our multiply one. They did to the 5 halves because it doesn't tell us which way it needs to be. They gave us a square root and a square in both. So if we look, they say do it to the 5 halves. Okay, so we need to look for the domain here, and I'll talk about the way that they've done their domain notation in the book. Okay, back on this problem, we said it was all real numbers. Well, that means that you can go from negative infinity to positive infinity. Okay, and actually those get, when we talk about that type of notation, they get parentheses. Okay, like that. We haven't really done that notation thing. I'm not too worried about the domain part. You need to make sure you watch out for the square rooty parts. Okay, so they've got it set at this piece, which is still equal to the square root of x to the 5th, or the square root of x to the 5th, whatever way you want to type it. You're square rooting, so it's got to be above 0. Okay, so our domain has got to be x is greater than or equal to 0. So the way you could write that in their notation is you would write it goes from 0, and if you do a straight bracket, straight line equal sign, means it could be 0, and then it goes all the way towards positive infinity. But you can't touch infinity, so you put a curvy line. Not equal, curvy people. So curvy line, not equal, straight line, equal sign, can be, touch. Okay. Then we have to plug in a 9. So we go 9 to the 5 halves, which is the square root of 9 to the 5th. Square root of 9 is 3, so that's 3 to the 5th. So 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 and 243, and then 240, I think that was it, right? Because 81 was 4 times. Yeah, so it should be equals 243. So 243, our domain is greater than or equal to 0, and it should be x to the 5 halves. Let f of x equal 6x and g of x equal x to the 3/4, and find them in division and state the domain. Then evaluate the quotient when x equals 16. So we want to do f of x over g of x. So that means 6x over x to the 3/4. X and x have the same base. This is to the first, so that's actually 6 to the x, 6x to the 1 minus 3/4, which is 6x to the 1/4. Okay, and we could say 6 times the 4th root of x. That also works. We're even rooting, so my domain is still got to be x is greater than or equal to 0. You can't put negative numbers inside there and do that root. Okay, so there's my domain. Got it. Now I need to evaluate it. We're going to do 6 and the 4th root of, but instead we're going to do f. Actually, it would be, if we did our notation properly, it would be f divided by g of 16. We're plugging in there, right? So we're going to put in the 16. We're going to 4th root it. 2 and 8, 2 and 4, 2 and 2, 1, 2, 3, 4 twos. So that's 6 times 2, which is 12. That's what we mean by function operations. We're just taking functions and doing operations, adding, subtracting, multiplying, dividing. Okay. Here's a couple of sets. Try these, pause the video, and then come back and see what they are. All right, let's look at number 1. Let f of x equal negative 2, x to the 2/3, and g of x equals 7, x to the 2/3. We need to add them, and we need to subtract them, do the domain of each, and then evaluate them for 8. So we've got 2 problems to do in this one. So I'm going to call it 1A, okay? And we have to add them first. So negative 2x to the 2/3 plus 7x to the 2/3. They're the same kind, so we can add them. So negative 2 and 7 makes 5x to the 2/3 That's my piece. I'm doing a cube root. I can cube root anything. So my domain is all real numbers, or you could do the big heavy R with the double line, or you could say negative infinity to positive infinity with curves because you can't touch infinity. So there's my domain. And then I have to evaluate it for 8. So 5 times something to the 2/3, and we're going to put an 8 in there. Let's say we got a third root 8, 2 times 4, and 2 times 2. It's 3 2s. So that's 5 times 2 squared. And 2 squared is 4, and 5 times 4 is 20. Okay. I'll switch colors for B. And we have to subtract them. Negative 2x to the 2/3 minus 7x to the 2/3. Negative 2 and negative 7 makes negative 9x to the 2/3. The domain, and really it would be like f minus g of x equals that, because we didn't get a new name for it. We don't get to call it h yet. They didn't tell us. Okay, but it should be negative 9x to the 2/3. So that's negative 9, and don't put the x in there. We're replacing it with an 8. We just did the 2/3. We just third root of 8. We know is 2. 2 squared is 4, and so that would be negative 36. Okay. Now let's look at number 2. Number 2 takes two new equations called f and g, and we have to multiply them, and then we have to divide them. So let's multiply them and then divide them. So let's look at 2a. We're going to do multiply. So 3x times x to the 1/5. Okay, so I'm supposed to add the exponents here because it's same base, and that's a 1. But if I'm going to make it into fifths, it's going to be 5/5. 5/5 and 1/5, so that's 3x to the 6/5, just like that. Okay, and then we have to evaluate it for 32. Oh, we have to do the domain. It's an odd root, so it can be any number. So my domain is all real numbers. So I got that, and I got that. And now we're going to do 3 times something to the 6/5, and we're going to do 32. 2 and 16, 2 and 8, 2 and 4, 2 and 2, 1, 2, 3, 4, 5 2s. So 3 times 2 to the 6th. Okay. 3 times 2 to the 6th. Let's see, 2 to the 5th was 32, so 2 to the 6th is going to be 2 times 32, which is 3 times 64. And 3 times 60 is 180, and 3 times 4 is 12, so that should be 192. Okay, ran out of room there. Now let's look at B. We have to divide them. So that is 3x over x to the 1/5. Well, that's 5/5, and I subtract them, so it becomes 3x to the 4/5. There's that one. My domain is all real numbers, because it's still the 5th root. We really only have to worry about square roots and then x's in denominators. Okay, so that's my domain part, and then we got to plug it in. 3, we're going to stick in the 32 to the 4/5. We figured out the 5th root of 32 is 2, so that's 3 times 2 to the 4th. 2 to the 4th, 2 times 2 is 4, times 2 is 8, times 2 is 16, so that's 3 times 16. 3 times 10 is 30, 3 times 6 is 18, so that's 48. That's how it works. Okay. Performing function operations using technology. Okay, so you can actually use the graphing calculator. Desmos doesn't work so good for this. I haven't figured out how to do it on Desmos at all yet. But your TI-84 calculator does do this. So I'll show you how to do that. You can type these into the calculator, And then you can use it to do all of the function things you want to do. Okay? So if f of x equals the square root of x, and g of x equals the square root of 9 minus x squared, we can type this into y1, and we can type this into y2, and then we can just do y1 plus y2. And we can even do it for as they ask. They want us to do it when x is 2. So we can do it y1 when you put in a 2. So this is like function notation. Take equation y, plug in a 2, and add it to y2 when you plug in a 2, and we can get the answers. So let's pull up the TI-84. I tried a couple of different kinds of 84 calculators, a couple of free ones, and none of them are as good as this one I bought for $5. So Graph and Calc 83, that's where it's at. What we're going to do is we're going to take these equations and we're going to type them in, like if we were going to graph them. So I'm going to do second square root of x, and then in y2 I'm going to do second square root 9 minus x squared. And now I've got them both in for those places. So then I'm going to quit back out to the main screen, and here's where I'm going to do all of my math work. And here's how it works. There's a button over by the arrow buttons just below it says vars. It's for variables. We have done y variables. We programmed y1 to be the square root of x, and we programmed y2 to be the square root of x minus x squared. So all I have to do is pick y1 and then say, and do it with a 2 stuck in it, and add vars y2 and do it with a 2 stuck in it, and push enter, and bam, I get 3.65. So that's approximately 3.6, let's see, what'd they say? Round it to 2 decimal places? Yep, okay. 6.5. When we're doing 2 decimal places, you're gonna have 2 places. The first place is what it is. The second place depends on the third place. We won't write the third place, but it tells us what to do with the second place. We have a 0, that's 4 and below, so we stay right there. Okay. Now, we could do this the long way with putting the 2 in there, and we could say, okay, take the square root of 2 and add the square root of 9 minus 2 squared, and we should get the exact same answer. It just takes what we put into the y's and runs it. So what's nifty is on your calculator, you can either push the up arrow, or you, if it's touchscreen like mine is right now, you can go back up to that, push enter, it retypes it, and then just go back over to the plus, and then just go, well, let's run it for minus. Okay, so y1 of 2 minus y2 of 2 is about negative 0.82. And we can go back up there, we can run it again, we can pick this, and we can go, well, then let's multiply them. And so when we do y1 of 2 times y2 of 2, we get 3.16. And then we need to do divide. So we'll go again, and we're going to change that out for a divide symbol, and we're going to push enter, and we get, I have to write it over here, y1 of 2 divided by y2 of 2, we get about 0.63. And so we get all 4 answers nice and easy. The long part is the setup, where you got to go type it in, and then you come back and you got to do all the typing. But once you get them typed in, you can run any number through them that you would like. It's kind of a cool deal, okay? So, niftiness with technology. All right, solving a real-life problem. Real-life problems are going to be decimal places. We're going to use the calculator to do it. So, for a white rhino, heart rate R in beats per minute and lifespan S in minutes are related to body mass M in kilograms. You see how the M is the variable for mass, R is for heart rate, S is for lifespan, and now we've got functions. So R of M, the heart rate, according to the mass, is equal to 241 times M, the mass, to the negative 2.5 or 0.25. And S, the lifespan, according to the mass, equals 6 times 10 to the 6th M to the 0.2. find r times s, and then explain what it means. Okay, well, we got to find r times s, and then explain what it means. So, I'm going to go calculator. Y, I'm going to clear out these guys, and I'm going to put in the first one. 241 x to the negative 0.25. And the next one is parentheses 6 times 10 to the 6th, close, x, and we are to the 0.2. Now, what it doesn't get me is what all of that means, right? But I'm going to be able to calculate anything they want me to calculate if I did it. It actually doesn't say to calculate anything, so I may have wasted my time on that. But that's how you type it into the calculator. So if we wanted to say that the mass of the rhino was, 1,000 kilograms or whatever, we could just put that in for our x whenever we type that. All right, so they want us to do 241 m to the negative 0.25, and then we're going to do times 6 times 10 to the 6th m to the 0.2. Well, let's figure out what's 241 times 10 times 10 to the 6th. Oop, delete, over, next, blah. Okay, well, that's a lot. Let's see, 1, 2, 3, 4, 5, 6. We're at millions, trillions. It's freaking big. It's huge. All right, so how many decimal places would we have if we wrote it in scientific notation? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we could say 1.446 times 10 to the 9th. And then we got to deal with the m's part. M times m. Base is the same, so we add the exponents. So what is 0.2 plus negative 0.25? So to the negative 0.05. That's what we'd get there. I multiplied the 241 times the 6 times 10 to the 6. 6 times 10 to the 6th means a 6 with 1, 2, 3, 4, 5, 6 zeros after it. We ended up getting, when we multiplied that times 241, 6, 4, 4, 1. We got this. So when we shrink that back down to scientific notation, you're going to go all the way to where you have a single digit in front. You can write the decimal places that are important, and then all of those decimal places, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 places. That's the exponent you put on the 10, because that's how many decimal places to go to the right. And then the m's, just add the exponents. Okay? All right. You can try these out. Take a pause, try them out, come back, see what the answer is. Okay. Let f of x equal 8x and g of x equal 2x to the 5/6. Use a graphing calculator. Ooh, we like that. So I'm going to go to y equals and clear out my business. The first one is 8x. The next one is 2x to the, and then 5/6. So I'm going to do parenthesis 5 divided by 6. You can write it like that. You can go back in there, delete all of that stuff. You could do alpha y equals n over d and do 5/6. Whatever your calculator will allow, that is fine. And then we're going to quit. So we want to do all of them when x is 5 and round to 2 decimal places. Okay, so number 3, I'm going to do vars 1 and of 5 plus vars 2 of 5 enter. So y1 of 5 plus y2 of 5, or I could just write it as f plus g of x is about, what the log's doing on there? Oop, go back up. Undo. Oh, well, dang it, I lost it. y1, 5, and y2, 5, and I should have put a plus sign, enter. All right, 47.65. The 7 makes the 4 go up, so 47.65 approximately. F minus g of x. So I'm just going to retype that and stick a minus in and run it. 32.35 f times g of x. We're going to, I don't want you, and then we're going to multiply. 305.89, the 9 makes the 8 go up, and f divided by g of x, and enter, change it, divide it, enter it, 5.23. That's what we get for all of those. Okay. In example 5, explain why you can evaluate f plus g of 3, f minus g of 3, and f times g of 3, but not f divided by g of 3. Well, that's a great question. Well, we're going to do the 6th root of 3, and then to the 5th. Well, let's see. What happens if we put a 3 in there? All right, so 2 is 3 to the 5 divided by 6. There you go. That's an interesting question. Why can't you do f divided by g of 3? Oh, interesting. Here we go. So let's look. We do 8x over 2x to the 5 sixths. This is 6 sixths. That makes it 4 times x to the 1 sixth. Well, I don't know why. It's a very interesting question. Let's see if they tell us anything. Okay, that's that page. Keep going. Rhino explains. Okay, interesting question. What if we go to the table of contents and we do selected answers? Chapter 1, this is what you should do when you're doing your homework and you're not sure and you look. Let's see if it's back there. Monitoring progress in 5.1. Of course, it's not in that book. Well, let's see if I can pick a different book. They don't have my teacher book. Well, look at them. But why wouldn't we be able to evaluate for 3? I think you can evaluate for 3, because 3 doesn't get you a 0 in the bottom, so that's not a problem. I say you can, but we'll see. I know where I can look. Let's go to my drive, and let's just pull up that book, shall we? City Math, The Mind of a Teacher. Big Ideas Books, Algebra 2, Textbook, Teacher Edition. We're going to go down to Chapter 5, Section 5. Oop, passed it. Let's see, Chapter 5, Section 5. And awesome. Too far. There's that rhino. Because g of 3 equals 0. Why does g of 3 equal 0? 3 to the 5 sixths times 2 doesn't equal 0. So I don't think they're right. But that would be why you couldn't. It would be if it made it 0, but it doesn't make it 0. I think the book is wrong, which happens sometimes. That's okay for them, because we just typed it over here, right? 2 times 3 to the, and I'll do it as a fraction this way, 5/6. You get 4.99999. That doesn't give you 0. They must think that that's a different problem. So you can do all of them. There isn't a limit. You can't do it of -3. That would be a problem, because you can't do the 6th root of a negative number. It'd be imaginary. So, long exposition to say, book's wrong on that one, but you can evaluate all the rest of them, and that one. Use the answer in example 6a, so that was back here with the rhino. Boom. And find the total number of heartbeats over the lifetime of a white rhino when its body mass is 0.17 times 10 to the 5th kilograms. Okay, so we just have to take that number, 1.7 times 10 to the 5th, and plug it into this equation for m. So 1.446 times 10 to the 9th times, what did we say over there? 1.7 times 10 to the 5th to the, and then what was our little exponent? Negative 0.05. Enter. And so, how many heartbeats? Let's see, count the things. Let's see, 791,855,334, probably 335 when we round it, because it's a heartbeat. You're not going to have sum of a heartbeat. Your beat, it's going to beat or not beat, hopefully. That'd be the best for you. Okay, so that's function operations. Add them, subtract them, multiply them, divide them. Watch out for domains. If it's if the x is in a radical, it's got to be, that's even rooted. It's got to be positive, bigger than 0 and up. If the x is in the bottom, whatever makes that bottom 0 is a no-no. So like what they're trying to say on number 4, it couldn't be 3. Well, it can be. So I think they meant a different thing there for the g of x. If it did turn it to 0, then it wouldn't work.